In this video, we'll talk about conditional probability. So if you want to talk about the probability of one event happening given that another event has occurred, or that another condition is met, so that one condition is met given that another one is met, then we call that conditional probability. And we write it like this, right here, and we say that as the probability of B given A. So you're looking at the proportion of occurrences of A for which B also occurs. And often that will be the number of occurrences of B divided by the number of occurrences of A. And we'll look at different ways, different formulas for figuring this out. So when the probability of A is greater than 0, the conditional probability of B given A, and the reason we put this condition greater than 0 on it is because we can never divide by 0. So the probability of B given A is the probability of A and B over the probability of A. So it's the probability that both happen divided by the probability that one of them happens. That the A happens, the one that you're given A. For any two events, the probability that they both happen then is multiplying the probability of one of the events by the conditional probability of the remaining event given the one occurs. So the probability of A and B is the probability of A times the conditional probability of B given A, or you can write it as the probability of B times the conditional probability of A given B. And these two are not the same thing. So let's look at this. At a certain university, 20% of freshmen smoke, and 25% of all students are freshmen. So we'll let A be the event that a student is a freshman, and B be the event that a student smokes. Now the probability that a student is a freshman is given here in this 25%. The probability that a student smokes given that they're a freshman is this right here. Because what we've done, and what we do with conditional probabilities, we set a condition that narrows things. So we're not just looking at students who smoke, but we're looking at freshmen who smoke. So we've conditioned it, we've narrowed it down to just freshmen, and then looked at smokers. So the probability that a student smokes given they're a freshman is the 20%. So we want to know, well, what's the probability that they smoke and they're a freshman? Well, to figure that out, we multiply the probability that they're a freshman times the probability that they smoke and they're a freshman. And we will find out that 5% of all students are freshman smokers. Now, two events A and B that both have positive probability, non-zero, they're independent if the conditional probability of B given A is the same as the probability of B. In other words, that condition of A happening has no effect whatsoever on the probability of B happening. Which, if we go back to our definition of independent events, being that one does not depend on the other, that they are completely separate in the conditions that make them happen, then that will make some sense. So, if our general multiplication rule tells us that the probability of A and B is the probability of A times the probability of B given A, then we can say that for independent events, it's just the individual probabilities multiplied, because these two, the probability of B given A and the probability of B, are the same. Now, tree diagrams can be really helpful for solving probability problems that are in different stages. And they combine a lot of the basic probability rules together to solve something like that. So the probability of reaching the end of a complete branch, and I'll show you a tree diagram in a minute so you'll see what the branch is the product of the probabilities along the way, using the multiplication rule. And the probability of an event then is found by adding all the ends of branches that are part of the event. So we combine the multiplication and the addition rule. So let's look at an example to see how this happens. I'm going to look at binge drinking and accidents. So at a certain college, 30% of the students engage in binge drinking. Among college-age binge drinkers, 18% have been involved in an alcohol-related automobile accident, while only 9% of non-binge drinkers of the same age have been involved in such accidents. So we're going to let event A be having an accident related to alcohol, and B, you're a binge drinker. And so you can look through the information I've given you and figure out that the probability of A given B is 0.18. 18% have been involved in an alcohol-related accident among binge drinkers. So that's the probability that you've had an accident given that you're a binge drinker. Only 9% of non-binge drinkers have been in such accidents. So that's the probability that you've had an accident given that you're not a binge drinker. And then 30% of them are binge drinkers, so the probability that you're a binge drinker is 30%. And we want to know, if we just take a student at random, what's the probability that they've been involved in an alcohol-related automobile accident? So that's kind of complicated. The tree diagram is going to help this make a lot more sense. So we put these things on the tree diagram. So first of all, we have these branches that go to binge drinker and non-binge drinker. 30% are binge drinkers, 70% are non-binge drinkers. And then if you're a binge drinker, 18% have had accidents and 82% have not. Of the non-binge drinkers, 9% have had accidents and 91% have not. And then to figure out binge drinkers who've had an accident, we're going to multiply 0.3 times 0.18 to get 0.054. That's the proportion of the entire population that are binge drinkers that have had accidents. And we'll do the same. We'll do this multiplying all along the way to get these four numbers right here. And we're looking for all the ones that have had accidents. So we want the proportion of students that are binge drinkers that have had an accident plus the proportion of students that are non-binge drinkers that have had an accident. And those are those two numbers in green. And when we add them together, we get 0.117. That's the probability that a student taken at random out of this population that we've described has had an accident related to alcohol.